Hello, folks, and welcome back. Today we're going to get started on covering the first day of trig, but in order to be able to get there on this, we need to, well, kind of brush up on a few things. So first thing we're going to do is we're going to touch on the special right triangle rules, which you remember from geometry, or if you don't, you might want to make sure that you're paying especially close attention to there. And we'll also touch on the whole SOHCAHTOA thing. So we're going to be using the definitions of trig functions to help us to find something, and we'll use the special right triangles to find missing sides. Yes, you do have some Math Excel to mess with, and there is a worksheet posted that will give you a little bit of practice. So let's get started first off with your special right triangles. The main thing I'm going to mention here is the fact that we had two special right triangles. We had the 45-45-90 and the 30-60-90. For many of you, this is something that you brushed up on and are relatively okay with because the rules are pretty simple. All you have to do is figure out how to get from a leg to the hypotenuse in 45-45-90 and how to get from the short side to either kind of the medium or the long side in a 30-60-90. Now, let's real briefly work our way back, because the biggest issue that most of the time students seem to struggle with is, how am I supposed to know when it's the square root of 2, and how do I know when it's the square root of 3? Well, actually, it's a pretty easy way to memorize it, because guess what? How many sides do I have the same in a 45-45-90? Oh, that's 2. How many angles do I have are the same in a 45-45-90? That's 2. So guess what? We have in the 45-45-90 going to multiply by the square root of 2. On the other hand, we take a look at our angles, and I've got, let's see, 3 different angles in here. I have 3 different sides in there. So guess what? That's a pretty good indication that it's going to be the square root of 3. And by the way, all of the angles are multiples of 3. So to get from the shortest side to kind of that medium length side, all I need to do is multiply by the square root of 3. And I double it when going from the side opposite the 30 to the hypotenuse, or the short side to the longest side. Okay? Hopefully, not too many questions on this, and hopefully last year you had a teacher that did a decent job of explaining. Should you have that memorized? Yes. How come? Because we're going to keep bumping into it over and over again. So let's take a look at an example problem. Ready, set, here we go. Now this one's going to be kind of easy, and I realize that. You have to recognize, okay, fortunately, whenever possible, we would like to start with the short side. And how do I know? Because it's going to be opposite the smallest angle. So I take my short side, and what do? I go from my short side to my medium, which again is opposite kind of the medium-sized angle. And I'm going to say, well, that's just going to be 3 times the square root of 3. And then when I'm going from the short side to the hypotenuse, or the longest side, I just have to double it, and you're done. Not too bad. Hopefully, not too challenging either. Okay, let's take a look at this one. Here we've got a 45-45-90, and we're saying, yay, I like 45-45-90s because the 2 legs are identical. They're both the same. And then we go to the hypotenuse, and we just multiply that by the square root of 2. And we're going, hey, that's not awful. And I'm going to say, no, it's not. Make sure that you're relatively comfortable with it. All right, let's see, how can it get a little bit more challenging? Well, when I've got something like this, I remembered that how I'm going to get from my leg to my hypotenuse is I multiplied by the square root of 3. The problem is I'm going backwards. Well, if I multiply by the square root of 3 to get to the hypotenuse, what I'm going to have to do is divide by the square root of 3 to get to the leg. All right, well, that's not incredibly challenging. Let's see what I can do on that. So I'm going to say I've now got 6 over the square root of 2. And then we rationalize this. And again, remember, rationalizing is not incredibly difficult. You just pretty much multiply the denominator, multiply by that square root that's in the denominator and come up with it that way. So I'm looking at 6 square roots of 2 over, and the square root of 2 times square root of 2 is the square root of 4, which reduces just to be 2. And so I'm looking at 6 over 2, which is going to be 3 square roots of 2. And since I've got one of those legs, I have both of those legs because they're always the same. Well, let's take a look at another one. How about something like this? And on this one, I'm going to say, well, at least it's not the one with the square root. Remember, how did I get from here to there? I multiplied it by 2. So because I'm going backwards, I'm hoping people recognize I'm just going to divide it by 2, which gets me 4. And then I just multiplied 4 by the square root of 3 to find this missing side in here. And that's, once again, not too bad. Again, hopefully your teacher harped on that a little bit last year. Okay, let's keep rolling then. See what we've got on this one. That's the one that's supposed to have a square root of 3 in it. Yes, it is. And it doesn't. So what do I need to do? Again, refresh your memory. How did I do that? I took this side and I multiplied it by the square root of 3 to get that. But if I'm going to go the other direction, I need to divide by the square root of 3. Okay, well, we're going to take 6, and I'm going to divide by the square root of 3. I can't have a square root in the denominator, so let's multiply by square root of 3 over square root of 3 here, and I get 6 square roots of 3 over, well, square root of 3 times square root of 3 is just going to get me 3, so I'm looking at 2 square roots of 3 when I reduce that. All right, well, when I divided by the square root of 3, I'm getting down to 2 square roots of 3. It's not pretty, but it still gets there. All right, now what? I still need to find my y, and I'm going to do that by, well, remember, that's the one that's pretty easy. All you need to do is just double it to get there. So, well, let's multiply it by 2. 2 times 2 square roots of 3 is going to get me 4 square roots of 3. At which point, there's generally one person that's going to say, don't I have to multiply the square root of 3 by 2? And the answer is no. You only multiply together the like terms. And since this is just a number as opposed to a square rooty number, I'm just going to multiply that one through by the 2 that's up here. Okay? All right, and let's take a look at another one here. And I've now got this. Okay, give it a second. And again, you can pause this at any point to try and get someplace. And I'm now looking at 7 square roots of 2. How come? Because they're both legs in a 45, 45, 90. So therefore, they have the same measure. Yay. All right, how do I get from the leg to the hypotenuse? I'm hoping that people remember that I'm multiplying by the square root of 2, which means I'm looking at 7 square roots of 2 times the square root of 2. And I'm going to say square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is going to be just 2. So I'm looking at 7 times 2, which is 14. Cool. All right, let's keep rolling, see what we can get to next. What I would say is pause it and see what you can do about this sort of thing. Again, I'm pausing, and you guys pushing the pause button in the YouTube land. Okay, and hopefully you've gotten it done or done your best, even though this may not be necessarily the friendliest thing. Because how come? You're getting fractions. And trust me, folks, this is one of those ones, and I can honestly tell you this problem and its corresponding one over here are two of the most important things that we're going to have over the next couple weeks. Now, what do I need to do? Again, hoping you remember that when I went this way, I multiplied by 2. So if I'm going in the other direction, I'm just going to divide by 2. Well, that's not hard. 1 divided by 2 is a half. Don't give me 0.5, please. Next, all right, well, how do I get to that other piece? I do that by multiplying by the square root of 3. And fortunately, this is going to be pretty easy, so I'm just going to take a half times the square root of 3, and we simplify that to be the square root of 3 over 2. Take my word for it, these two answers will be significant. If you have any questions, I would recommend asking me or somebody that knows what's going on with this. Please take a look at this one. Okay, it's another significant one. and I'm going to say, what is my rule? Again, my rule was getting from the leg to the hypotenuse. All I had to do was multiply by the square root of 2. Okay, that's not bad, but I'm going the other direction. So I'm going to say I've got 1 divided by the square root of 2. Can't have that as my answer because I've got a square root in the denominator. And we're going to say, so that's square root of 2 over square root of 2 to rationalize the denominator. 1 times the square root of 2 is square root of 2. And square root of 2 times square root of 2 is 2. So I'm now looking at functions that look like this. And hopefully that's not that bad. So please keep these two in mind also. Going once, going twice. Oh, wait, nobody's here to ask me any questions. So we're going to move to SOHCAHTOA. Now, SOHCAHTOA is just a mnemonic device for helping us to remember which way things go. And we're going to say, again, sine is just the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is opposite over adjacent. The biggest question that I generally have students running into is they don't have a problem with the hypotenuse because guess what? That right arrow, or I'm sorry, right angle points at the hypotenuse, and people don't have that much of a problem figuring out what that is. Next, how about trying to figure out which one is adjacent and which one is opposite? Well, what I would do is I would figure that this is a person sitting in the corner, and they'd say opposite of them is going to be this side, and adjacent or next to that person is going to be this side. Now, I've always got one smart aleck that's going to say, well, this one's adjacent too. Yeah, but guess what? It's more significant to have the hypotenuse, so I want to go with that title as much as possible. And then what sine, cosine, and tangent are a ratio of the sines. So if you want to memorize it through SOHCAHTOA, or you've got another technique, or honestly, you can go on YouTube and sort of look at some techniques for songs that could have been written about this. There's all kinds of stuff out there. But I will tell you it's worth your time to have that memorized and down pat. Okay, let's see what we can do on one of these sorts of things, which fortunately is, once again, not horrible. How do I go about figuring this stuff out? Well, what I'm going to do here is I can either use my Pythagorean triples, 5, 12, 13, and if somebody bugs me in class on Tuesday or Wednesday, I should be able to help you to get these down. I will tell you my answer is 13, but if you don't recognize that, you're going to have to say 5 squared plus 12 squared is going to get me c squared. And so I end up with 25 plus 144 is c squared, and that's going to get me 169, and the square root of 169 does give me 13. Okay, not hard to do, but it'll come in handy to have that memorized. Again, ask me about it in class on Tuesday. All right, now, how do I go about figuring out what sort of values I've got for sine, cosine, and tangent? Well, all I have to do is figure out what sides I'm dealing with. Well, sine is opposite over hypotenuse, and I say my sine that is opposite there is going to be 5. So I'm going to say 5 over, and my hypotenuse is 13. So the sine of my angle is 13 or 5/13. Next, I'm going to say, well, cosine is adjacent over hypotenuse, and adjacent means next to. I'm going to say my adjacent is 12, and my hypotenuse is 13, so 12 over 13 there. Next up, tangent. Well, what can we do with tangent? Tangent is just going to be opposite over adjacent. My opposite side is 5, and my adjacent side is 12. And that's it. That's all. Nothing exciting in that. Well, what else can I potentially do with this sort of thing? Well, we could try and do something like this. Once again, pause if you need to. Find your C, And if you found your C, I'm hoping that many people have already gotten this down. And again, it's one of the triples, so I can do that fairly quickly. And now I'm going to say, okay, sine is opposite over hypotenuse. So I'm going to say 6 over 10. But I do want to reduce this if I can, so I'm looking at 3/5. Next, cosine is going to be adjacent over hypotenuse. So I'm looking at 8 over 10, once again reducing 4/5. And finally, we're going to go to the tangent, which is just going to be opposite over adjacent. So I'm looking at 3/4 there. Okay, hopefully nothing too earth-shattering in that. Next, let's see what we've got here. Looking for our missing side, and unfortunately this one is not a Pythagorean triple, so I'll have to probably use the full Pythagorean theorem, which is going to get me 1 squared plus b squared equals 3 squared. Okay, 1 plus b squared is going to get me 9, and so b squared is going to be 8. So I'm looking at a b value that is the square root of 8. Now, for our purposes, we are not going to try and simplify the radical. We just don't have time in the year right now. But what we can do is still try and find things out and find the ratio of sides. All right, so I'm going to say sine is going to be opposite over hypotenuse, so I'm looking at 1 over 3. Cosine is adjacent over hypotenuse, so that's going to be square root of 8 over 3. And then the tangent is going to be 1 over the square root of 8. And I'm probably not going to have you bother to try and rationalize that either. Okay, then let's see what we've got down here. Why, I've got another problem. I would recommend pausing this and seeing if you can get there on your own, because if you can, that's going to be a wonderful thing. If you can't, hopefully you will be able to watch me work it from there. So give me a quick timeout, a couple seconds to do stuff, and let's see what we can do here. All right, so I'm going to say leg plus leg has to equal hypotenuse squared. So 1 plus b squared equals 25. And I'm looking at 24 equals b squared. Okay, so therefore my b is just going to be the square root of 24. Yep, for our purposes, that'll work just fine. Next up, I'm going to say the sine is going to be opposite over hypotenuse, so 1/5. The cosine is adjacent over hypotenuse, which is 24/5. And finally, we're going to say that the tangent is going to be 1 over the square root of 24. And we're all set then. So hopefully now we've got our 30, 60, 90, our 45, 45, 90, and now SOHCAHTOA. Now let's see what we can do about finding this sort of thing. Okay, when the problem is written a little bit differently, this becomes a bit more of something we need to work on. Now what we can do is the proportion of the sides is 1 to 2. Now, just in case anybody's curious, that does not mean that this side, which is my opposite over my hypotenuse, has to be 1 and 2. It just means that when I reduce my fraction, I'm going to get 1 and 2. So this could be 5 and 10. It could be 15 and 30. Any of those things work, and we can actually do it. But we're trying to be lazy. So what we are going to do is we're going to start with the 1 and the 2, and we need to find our missing side. So I'm going to do the Pythagorean theorem and say it's going to be 1 squared plus b squared equals 2 squared. Okay, well, 1 squared is 1, b squared just b squared, and 2 squared is 4. So I'm going to say that b squared equals 3. So I'm now looking at b equals the square root of 3. So therefore, my box now can get filled in by the square root of 3. So I'm going to say cosine is adjacent over hypotenuse, square root of 3 and 2. And the tangent here is going to be 1 over the square root of 3. You know something? These two numbers look kind of familiar to me. Wait a second. Let me go back to Wait. Yes, that's exactly what I'm looking at. It's the exact same problem. You remember when I said we're going to keep bumping into these sorts of numbers in here? Yeah, that's kind of why. So please make sure that as you're working this stuff, you're drawing these connections. Okay, so let's see what we've got down here to try and do this problem. It's not as pretty and it doesn't do anything special, but just see what you can do about solving for stuff. All right. And again, it says that the tangent of theta is 1 over 4. Once again, it doesn't mean that the actual values are 1 and 4, but it means that the ratio of the side lengths is going to be 1 and 4. So I suppose this could be like 4 and 16. That would work. But we would like to use the easiest numbers possible, so I am just going to use 1 and 4. And now we just need to find our hypotenuse. So I'm going to say 1 squared plus 4 squared has to get me c squared. And 1 squared is 1, 4 squared is 16, c squared. And c squared has got to get me 17. So therefore, I'm going to say that my c is the square root of 17. Now, even though it's a square root, I'm not going to freak out about this. I'm going to say, let me see if I can just fill some stuff in. So here we go. Sine is opposite over hypotenuse, 1 over the square root of 17, and we're good. Cosine is going to be adjacent over hypotenuse. And, oh wait, we're done because we've got our 3 trig functions. Cool there. Now, that's all I've got for you today, folks. So you can go ahead and get to work on your Math Excel, and I'll look forward to seeing you in class.